Hello, assalamu alaikum, all viewers and dear students and ladies and gentlemen. Once again, Maqbool Islam is in front of you. Today, our topic is Theorem 9.2 from the 10th class book of the any country. So, the theorem is the statement of theorem, a straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular. This is the statement of theorem. First we write the statement of theorem. A straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. A straight line drawn from the center of the circle to bisect a chord which is not a diameter is perpendicular. Which is not diameter means that here, so the chord does not pass on the center of the circle. So it is called which is not a diameter. Now first of all, from the statement, a straight line we are needed to draw from the center of the circle. This is given to bisect a chord. To bisect a chord, so a straight line from the center of the circle is required. So first of all, we draw the circle. We draw the circle, and this is the center O, and draw the chord P and Q. And perpendicular straight line drawn to the perpendicular OR. So this is the statement given that, and given we take a circle with center O and draw the chord PQ, and here R is the midpoint of R is the midpoint of PQ such that PR is congruent to RP, such that PR is congruent to RQ, or we can say that QR. So this is a straight line from the center of the circle to bisect a chord. Straight line means that here OR, which is the perpendicular line. So we have drawn and bisect the chord R. R is called the midpoint of the chord PQ. Now we want to prove that OR, a straight line which is perpendicular which is not a diameter, that is not a diameter because the line is not passes on the center, so that is not a diameter. A is perpendicular, so it means that OR is perpendicular to PQ. So this is the to prove OR is perpendicular PQ. Now we are required to join. Construction is required because here radial segment radii is required. Similarly, we join this construction, and construction also we give the name here angles 1 and angles 2. Join O to P and Q. Suggested here, suggested the angles angle 1 and angle 2. Proof. Statements and reasons. So here there are the, for the comparison we get two triangles OPR, OQR. These are the two triangles one to one correspondings. We take and comparison of two triangles. One triangle is this one. The other triangles we get here. So, in comparison of triangle OPR one to one's correspondings, triangle OQR one to one's correspondings. OP is congruent to OQ, radii of the same, radial segment, radii of the same circle. PR is congruent to RQ or QR. So corresponding side of given, corresponding side of congruent triangles, that is already given. So OR and OR is common. So triangle are congruent. Triangles OPR is congruent. Triangle OQR. Side angle by side angle triple S postulates. Side by side postulates. So it means that here angle 1 is congruent angle to corresponding right angles, or measurement angle 1 is equal to measurement angle 2 corresponding angles of congruent triangles. So measurement angle 1 is equal to 90 degree. Similarly, measurement angle 2 is also 90 degree. So measurement angle 1 plus measurement angle 2 is equal to 90 degree plus 90 degree, we get 180 degree supplementary angles. So from the equation number first, we can say that here from equation number first, measurement angle 1 is equal to measurement angle 2. So measurement angle 1 is equal to 90 degree and measurement angle 2 is equal to 90 degree. So therefore OR is perpendicular to PQ chord, which is the required proof. The same theorem, just like it is the reverse of the 9.2, perpendicular drawn from the center of the circle bisect a chord to bisect a chord at. This is the statement of perpendicular drawn from the center of the circle to bisect it. One of the perpendicular is required, that is already given from the center of the circles. Now, first of all, we draw the circle and center O. One of the chord hairs P and Q. Perpendicular drawn OR. So in this statement, it means that here OR is perpendicular. OR is perpendicular to bisect the chord. It means that here we are required to prove that one the corresponding sides of this one are equal or not. So given we have a circle with center O and OR is perpendicular to PQ and PQ is the chord of the circle. We want to prove that perpendicular OR is perpendicular PR is the corresponding side of PR is the corresponding side of PR, we want to prove that PR is congruent to RQ. We want to prove this one, the corresponding side of congruent triangles. Now, construction. Join O2, P and Q and labeled label the angles angle 1 and angle 2. Proof statements and reasons. We get two triangles O P and triangle POR, or we can say that OPR. This is your choice. You start from anyone. POR and triangle ORP and triangle ORQ. One to one correspondings. So here's OR is the common. And OP is congruent OQ, radial segment, radii of the same circle, angle, angle, angle ORP is congruent angle ORQ. Each is right angle, each is right angle. So the above triangles are congruent. ORQ means that here we discussed here the sides, hypotenuse, sides, postulates. So it means that here angle 1 is congruent to angle 2 and PR is also congruent to QR. So we can say that angle PR is congruent to RQ, corresponding side of congruent triangles, corresponding sides of congruent triangles. That is the required proof. Thank you very much for watching. Once again, appreciate you in advance to everybody. Inshallah, in the next video, step by step, we will proceed. And please pray for me. Thank you very much once again.